Good evening. Welcome to the Land Tamer stream. Yes, today was a big day here in Florida, Central Florida, not so very far from here where I live, west of Orlando. We had, of course, what you see on the screen, the wallpaper of the day, Falcon Heavy launch, and I have to tell you, I've watched a number of launches on, on YouTube. I've even been to a launch at Cape Canaveral at Kennedy Space Center. But I have to say, this was just about got me emotional watching this. I couldn't even watch it live. I'm so busy today. I couldn't even play it in the background. I work from home, and I could often just let stuff play in the background. Not happening today. I was very busy, but right after work, as soon as work was over, 5 o'clock, I went and watched this thing, and I was very moved. What an achievement, So we'll see where that goes. We got the NASA's SLS is coming up, and I know this is a networking, vlog / stream, but you just can't help it. I can't help it, especially your engineer, So we're gonna launch some packets today, but I even brought a little. I felt like celebrating. I said I'll do it on stream. I have a little bit of a whiskey for SpaceX and everybody that works at the company and space exploration in general. So great day in history, and it's exciting, to see what's going to come in the future. Anyway, let's get on to packets. We're going to launch some packets today. I'm actually going to do a little mini lab. I'm going to tell you why here in a minute. The agenda for today's vlog session is going to be a little labbing. And I gave you a hint here about EIGRP. Links of the day, though, is, again, sometimes, on occasion, I will allow personal topics to seep into the stream. Entertainment, rocket launches, weightlifting, you name it. But yeah, if you haven't seen it yet, definitely check it out. It's worth a watch, and you've probably seen it. But, watch the whole thing in detail. There's some details that they don't really explain all in the news that at the launch, the commentators give a lot of detail about, which is cool. Like, for example, launching, they have some material with all the names of like thousands of people who actually worked on the rockets. Was launched into space along with the Tesla Roadster. So anyway, vlog topics. Yeah, whiskey shot for space exploration. We do that occasionally here on the stream. Celebrating life. Cloud automation. So yeah, I'm getting more and more into this. I spent a good bit of time today working on automating, creating network objects in the cloud, using a Linux bash shell and various tools. So I'm all about, routing and switching, the core routing and switching on premise. But things are changing, and that's one thing I'm really excited about in my current position is, we're staying with the times. We're trying to stay, competitive, and we are very competitive and very forward-looking. And we've been in the cloud for a while, but it's really now getting down to some of my work and that I do on a day-to-day basis, and I'm really enjoying it. So who knows what the future post CCIE certification. I do know that I'd want to be more involved with automation, and particularly with some sort of programming tools. Not necessarily the tools, not going to matter so much as the theory, and depending on what's more beneficial for me at the time to automate, that's kind of what the tools will dictate. But yes, that's what I'm looking forward to in the future. My progress right now on studying, as you know, I'm not labbing really that much. I've been studying, and it's all about IPv6. As many of you know, I have a blueprint checklist, a blueprint chart, if you will, that guides my every waking moment of study right now. And that is getting all these particular blueprint topics that I've rated myself on. A number of them, quite a few are C, A through C. I want to get these up to a B, and a lot of these involve right now IPv6 because I never got to that section of the INE workbook. So I've been reviewing addressing schemes, taking notes, using the Necrocube flashcards, and reading, but in particular watching a lot of videos. So I'm going to continue to do that here later tonight. This is my study time. But I hit, in particular today, I hit an issue with EIGRP that is, I've always been weak on. If you've watched me any amount of time, if you've seen any of my past lab streams with EIGRP and composite metric, I've had problems. And this was not too difficult of a question. You know, usually I'll take a few minutes each day to run through some BOSON exam questions. And today I hit one that I've hit a couple of times and got them wrong each time. It's time to just lab it out so that it makes sense to me. It's EIGRP, and I've launched Viral, which I haven't done actually in a few days. And that reminds me, you don't want to let your Viral server, it's kind of a pain if you let it go longer than without booting up, I think 7 days or 10 days. So that's kind of a reminder to me. Fortunately, I made it in time, but your salt configuration will have to, you have to resalt your servers basically if you let too much time go by. I don't think we have here, of course. But I'm going to launch. Okay, yeah, I think we're good. I'm going to go ahead and launch the. What should I do here? We'll do basic. We won't do basic EIGRP routing. Let's do basic IP addressing. I think we'll load this topology. And we're going to set up, all right, here's what we're going to do. And I think we're done with this. Yeah, we'll move this out of the way. So we're going to play with some EIGRP metrics again. And let me launch the topology that we're using. Let's see, where's my, yeah, topology routing. Okay, so what I'm going to do is something new, really. I'm going to create, let's see. I'm looking over here on the left is output from the BOSON exam, which I'm not going to show on screen. But what we want to do is create a scenario. We've got one. Okay. This is probably a good one. So let's say router 3 to router 9. So we've got a couple of paths here. One, let's see. All right, I'm going to modify this a little bit. It might even be easier to start from scratch, but oh well. Let's just do it. All right, so we're going to say router 9 has a network here. This network here, 155.1.9.0. And it's not that big of a network. Okay, so we've got this network. And distance here is, we're going to say distance is 10. All right. And the bandwidth is going to be, well, let's see here. The bandwidth is going to be slightly different. So we're going to call this, I'm just going to say this is, in the exam here, this is like router, this is called router 5, or router E. Man, that is huge. Okay, that's router E. Distance is 10. And bandwidth is 100. Okay, just follow me. Just follow along here. We'll explain all this. 20, let's say. And let's make it blue or something. Okay. So this is router E. We have a router D. We have a router C. And we have a router B. We'll call this B over here. And this is router A. Okay, I'm going to have to do some different diagram. I'm going to have to do some different links here, but that's fine. We're going to have, first of all, router A to router E. Okay? So I'm going to put a link here. And this is going to be distance of 40. And bandwidth is 100. Okay? Boom, single hop. And so my target here, or the metric I'm going to calculate against, is to this route. 155.1.9.0. Okay? From router 3. Then we have through router D and router 3. And this is going to be, bandwidth is going to be 80. You see where I'm going with this kind of exercise, right? Okay, so this is this one path. And then we've got router D to router A. In this case, router 7 to router 3, right? The bandwidth is going to be 100. And the distance will be 10. Okay, then we're going to go from router E to router C to router A. We're going to have a number of lines here. And from router E to router C is going to be also 10 and 100. Pretty much the same distance. So we're going to go here. And then we're going to have a link from router C to router A. And this is going to be, bandwidth is 100, distance is 20. All right. And we have one more, which is router E to router B to router A. So we're going to have another link here. I know this seems nonsensical, but, you know, this is going to be bandwidth is 100, distance is 10. All right, so we have four possible paths. And let's put this up on the screen here. Let's put this in a little chart or something. Text edit's fine. Just good old text edit. Nothing fancy. So we're going to go again. Router A. And again, this is router A's metric. Oh no, metric to router A's 155.1.9.0. Okay. We need to calculate this metric, and we need to come up with what is the successor route, and who are feasible successor. Okay. Out of, we have R1 or router. Actually, hold on a second here. Yeah, we'll call this path 1, which is our router 3, to router 9. Okay, path 2 is ADE. Yeah, so put that here, and this goes here, right? So A to D to E. Router 3, and we'll just put A here. Traveling to router D, which is what? R7 to, of course, R9. Path 3 is going to be router 3A through router C. So boom, boom. Router 9E. And then path 4, router 3 to router B, which is router 1 to router 9. So we have 4 paths, right? So let's just look at these on paper. And we have router A to router 9. That looks like appears to be the most direct route, right? But our bandwidth from route, now this, in my opinion, and I'm obviously wrong about this, so we're going to find out where I'm wrong. But from router 9's, we use a cumulative distance, right? So the distance here is router 3 to router 9. The distance is 40. So I'm just thinking about the composite metric, right? There's a single link of distance, and the bandwidth here is 100. All right, let's look at path 2. And this is theoretical, right? We're going to actually configure this to be, it might be a factor of 10. But path 2 is going to be ADE or, yeah, ADE, router 3, 7, and 9. And the distance here, router 3 to router 7, the distance is 10 plus, well, I'm going to put a comma for now. And then 7 to 9 is 20. And the bandwidth on that link from 7 to 9 is 80. Again, this from router 9's perspective, right? What is my bandwidth? Yeah, what is my bandwidth to that link? Okay, so that's path. I think that may be where I've got things wrong. Now I'm looking at retrospect. So path 3 is ACE or router 3, 6 to 9. So router 3, router 6 is 20. And then 6 to 9, the distance is 10. And the bandwidth that way is 100 from router 9's perspective. Okay, path 4, 319 is going to be, oh, I don't have that here, do I? Bandwidth is 10. Yeah, I do. Wait a second. 3 to 1 is 100 and 10. And then 1 to 9 is 110. Yeah. Okay. So again, both these lengths of distance is 10 and 3 to 1. And 1 to 9 is 20. And the bandwidth here is 100. Okay. So if I look at the cumulative distance on these are all the same. So path 2 should be the successor route. And the feasible successors, now in particular, what we have to pay attention here to, I think, and the reason I say successor, even though these are all equal, this will be factored using the bandwidth. And the bandwidth here, oh, this is actually lower, isn't it? Yeah, the bandwidth is lower. Okay, so I would think that these two would use equal cost multipath. These should have an equal metric, because they're both within 100. Let's see, this is 3 and 4, so this is going to be, okay. Wait a second. 80. Yeah, bandwidth. First, I would look at the okay, obviously I'm obviously struggling here a little bit already, because I have what I think is right. That essentially these would be equal cost multipath. Well, maybe I'm right. All right, so I'm thinking 30 and 100, 30 and 100, 40 and 100, 30 and 80. This is the most attractive pass, so 3 and 4. So that would mean, would these pass the feasibility condition? These must be closer than, so, oh, I have to add. $180. Would these be closer? The reported distance is going to be 20 here and 40 here. This reported distance is lower. I would think this would be a feasible successor, but the answer key is showing me that this is wrong. Okay. So let's look at these. A and E. I'm just kind of checking against. Bandwidth is 100. Total delay is 50. I'm leaving off, let's see, A to E. Because, excuse me, I have not calculated this amount. That's where I'm going wrong. Okay. So on I am router 9, and I'm looking at this. I have to report this distance as well, don't I? So A to E, this is really 40 and 10. The total delay is 50. And then A to C to E. Yeah, I have to add that, don't I? That's where I was, okay, that's where I was getting it wrong. That's why I got this wrong. Okay. Total delay here, this will also be 40. And path 4, A to B to E. Hold on a second. $10, $20, $30. Okay. Where did I get 20 from? Okay, gotcha. All right. So this really is the route through B has the highest bandwidth and lowest total delay. Yeah, this is the successor route. Okay. I was not counting the link. See, in my thoughts, if I'm router 9, this is a directly connected link. It's right here. But EIGRP demands that I add the cost or the delay, or the cost, the metric, the delay at least to the path for reachability. So when I report this to router, to this router, I'm reporting a delay of 10. 9 says, hey, to get to this link, there's a delay of 10. And so router 1 says, all right, hey, router 3, if you want to get this, you've got 10 and 20. Router 3 gets it and says, oh, the reported distance is 20, but I had to add 10 because that's my distance to you. So, okay, all right. So this is a very fundamental key to learning this, it looks like. Router 9, there's a reported distance. We can't both count the distance of this link. So the way EIGRP works is when the router is forwarding the routing update outbound out of an interface, it does not consider the delay of that interface when reporting it to the upstream router. Router 9 is assuming that router 1 is going to add that distance. Okay, the table shows the route through B is the highest bandwidth and low. Therefore, the route for a route to qualify as a feasible successor, the metrics at the next hop router should be lower than the metrics of the best route. Wait a second. For a route to qualify, the metrics at the next hop router, at this router, should be lower than the metrics of the best route. Right, that statement is a very confusing statement. Okay, all right. So what it's saying is, from router 3's perspective, the metrics at the next hop router, the reported distance by the next hop router, should be lower than the metrics, the best route on the local router, me. So these will be the advertised or reported. Okay, so if we do a table for that, router B is going to report he has a distance of what? AD values. So he's going to say, hey, dude, 10, 20. My distance is 20, and my bandwidth is 100. Router C is going to say, hey, dude, my bandwidth is 100, and my distance is 10, 20. And router D, which is router 7, I'm going to say, hey, dude, my bandwidth is 80, and my distance is 20, 30. Of course, path 4 is the successor. These are feasible distances, right? These are advertised. Okay, that makes sense. So for a route to be a feasible successor, is that this advertised distance must be lower than this feasible distance. And in these cases, the feasible distance for me is 30. Oh, what were we missing here? E. Oh, I did not calculate this, did I? Router, there are 5 paths. No, that's path 1. Four paths, right. So A, B, E. I'm going to actually move these up, guys, because this is going to help me. Correlate it. A, B, E. Bandwidth 100. Total delay is 30. Yes. Path 2 is going to be ACE. And again, we have 140, right? ADE. ADE 80 and 40. And then path 4, A to E, is 150, right? Let's do this. Okay. These are the feasible distances. So looking at these feasible distances again, we have to compare really the best bandwidth is 100, path 1, 2, and 4. And the lowest distance is this one, yeah. So this is your successor route. Like we had. Now we have 3 possible feasible successors. Okay, so path 1, we're going to put it here just because it's in the chart. And, you know, we're going to go through A, B, E. This is the reported distance, or the advertised distance. So B is going to advertise what? A, B, E. So we're going to go A, B, E. So it'll be 10, 20. And the bandwidth is 100, right? It'll be 10, bandwidth is 100. 10, 10. The distance. Okay. So that is our successor route anyway. So he's not going to be a feasible successor route. But how about if we go through path 2, which is through router C. So path 2, A, C, E. And looking at it from router C's perspective, so path 2, ACE. All right, 10, 20. So his is 10 and 10, right? And bandwidth he's going to report is 100. So on paper, these look like equal routes, right? Okay, now let's look at router D. Path 3, which is ADE. Let's see. Okay, ADE. So we got 10, 30, and bandwidth is 80. All right, so we see that there. Does not look as good. And then we have finally path 4, which is through router E, just AE. And the bandwidth is 100. And he's going to announce his distance is 10. Make sure I have that right. Through router B, C. Through router D, it's 80 and 30. It's the worst one. And we have 110. So route through router C is a feasible successor because the AD from router C is lower than the feasible distance. Again, the feasible distance up here is 30. So we're looking for feasible successors to be less than 30. Simple as that. This doesn't count because this is our successor. So between these 3 routes, really, we see that through router C and through router E. Okay, and that's what the answer is in the key. All right, so the key is determining, and where I got this wrong again is counting the distance actually of the link and how that factors into the total distance. So that's what I was getting wrong. All right, well, I feel better. And I do actually want to sort of lab this up. So let's do some interfaces here. We need to build between router 6 and 9. So let's see, router 6. For your terminal, interface GI 0, 1, 6, 9. .1Q incap 69 IP address. Let's say 15.1.69.6 and on router 9 we'll have incap. This should be incap.1Q 69. Am I right, folks? Am I right? Am I right? That would do no shut for grins. Okay, so we need to build that one. We need to build 3 to 9. So we're going to have interface GI 0, 1, 39. IP address 15.1.39.9. And we're going to put this on router trace. And this will be 3. Okay. Okay. Will that work for you? Is that good for you? Good. All right. And then we're going to have 36. So interface GI 0, 1, 36, incap.1Q 36, IP address. I got to put a mask, people. Got to put a mask here. Okay. $36. And this will be .6. Okay. Whoops. Get your hand on the keyboard. Get in position. All right. So that's that interface. And then we need this one here. What is our distances? What are our distances now? Router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's just go over here, router 1. Oh, cannot connect. What's happening? Check in on our server here, see what's going on. Do 16.16139. What's the dealio? All right, let's see. Check in on our. Okay. 17000. Did I type the wrong thing? No, don't do that. Ping viral. Yeah, we got pingage. Got pingage. Routers are up. They all say reachable false. They usually say that, I think. Something is awry here. Did I not load this too many days in a row or something? 207. Oh, yeah, it's 7 days. No, we're good. Yeah, everything is good. Okay. That's not what I wanted to do. 1 through 16, 1, 6, 139. Connection refused. How dare you? All right, let's launch. Let's see what's going on here. There you are, via Maestro. Not what I had in mind at the moment. All right, so let's see. We also need to, we're going to do I have all my interfaces? Let's keep going while that loads. So we've got 6 to 3, 36. Now let's do router 1 to 9, and then we'll have all of our interfaces. Oh, this is the wrong, is that right? Hold on, what's running in simulation? What is running? Yep, typical topology that we know and love. Okay, he's refusing connection. Just not having it. I don't know what's happening here, folks. I'm going to reboot. Yep. We are going to restart this bad boy. Yeah, we're just going to forcefully firewall setup. Doesn't happen very often. We'll continue working on this. Router 1. And want a new interface, which is, let's say, call it 1.109. .109.1, and on router 9, this will be this 109.9. Okay, so we've got router 9 has 1, 2, 3 new interfaces. 1, 2, 3, that's right. Router 6 should have 2. Yep. Router 1 is going to have 1 new one. Yes. And all right, good. Good deal. Okay, well, I think I've realized the error of my ways here, hopefully. And what we want to do as well is modify the... I don't think... Yeah, we have to modify the distance in a couple places. We have to modify the bandwidth. So on router 7... Yeah. Router 7. Interface GI0179. Bandwidth. Gonna make it basically 80%. All right, Barrow is shutting down. And starting up. Okay, so we need to modify that bandwidth. We also need to modify the delay. This should be twice as much. I think the delay, I want to say, is 1,000. Oh, I think the delay is, or is it? Yeah, I cannot remember. All right, we'll wait for this to come up to see, but. Yeah, so I've been learning a lot about the test. Yep, make sure Nightbot's there. Okay. This may take a little time to load up. But let's launch. Yep, Service Center available. That's okay. We have terminals open. We do. Okay, that's all good. Oh, I don't want that. I want this. Yeah. Just go viral. Okay, Ubuntu, however you say it. Server at viral port 80. Yeah. All right, guys, I think I got it figured out. I'm not going to be able to lab all this on screen because it's going to take a while for this to come back up. I may have to do some troubleshooting. But we get the idea. Where I went wrong before is not including the distance of the local link. That's where I went wrong. That's why I got the issue wrong. But I'm not going to hold up too much more in the stream again. I'm not going to lab really much more tonight. We're going to get back to studying IPv6. And we're going to get back to working on our blueprint, watching videos. And again, thank you so much for tuning in to LAN Tamer Stream. Appreciate all the support and community. Check out our Discord server. Of course, I'm on YouTube, Twitter, Instagram, and may you have all the good bits. Happy learning, happy labbing. Take care, folks. We shall see you most likely tomorrow night.